Okay, welcome to lecture number 15. This class for the experiment today we'll look at servo motors and stepper motors. So first we'll start off by looking at the manual, in which we basically explain what are the various parts of a stepper motor, and then we'll look at the program of how to actuate the stepper motor in different modes. Okay, then we'll move on to servo motors. Okay, this is the manual for today's experiments. So it is a stepper motor first, and then we'll look at servo motors. So in terms of the stepper motor, the material that are required are the Arduino Uno microcontroller board, then the easy driver, the motor driver. Okay, so here there is a motor driver which does the sequencing of the pulses. Then we have the stepper motor itself, and then the power supply and modular battery which gives the power to the driver. Okay, and then the various connection wires and the motor itself. Now, parts of the experiment that we'll be doing today, first is familiarizing with the stepper motor and the driver, and then running the stepper motor in full and micro stepping modes. Okay, so this basically gives us a figure, or this figure shows us the different parts of the stepper motor. Now, this is something which was explained earlier also. So if you look at the stepper motor, it consists of the rotor, and then there is a stator which has the windings. So the windings are on the stator, whereas the rotor is the permanent magnets, and the permanent magnet rotor is divided into two parts. One is the rotor 1 and the rotor 2. Okay, and then this is also showing you the bearings of how the shaft is mounted onto the casing, such that the shaft can freely rotate. So this is the construction of the stepper motor, and I'll also be showing you opened up the view. That means we'll open a stepper motor and show you the inside before we move to the experiments. These are some things that we are required to know. First of all, calculating the step angle of the stepper motor. The step angle is calculated in this ratio, 360 degrees for one full rotation divided by number of phases into number of rotor teeth. So each of these projections here are called the teeth of the rotor on the rotor. Okay. So this is how you calculate the number of step angle for the stepper motor. So for one pulse, it will be going by one step. Now identify coil A and coil B using a multimeter. So this will show as we go along. Now this stepper motor also can be driven by or rather we require a driver to drive this stepper motor, and this is the Easy Driver version 4.4. And this stepper motor driver, as you can see here, has a coil A and coil B right at the top. And then we have the enable, MS1 and MS2, and then power in, and also the direction pin, whereas extreme right end is showing the direction pin. Okay, so by using this, we can basically drive the stepper motor using the microcontroller. Now, we have seen the two MS1 and MS2 modes, and depending on how you make the MS1 and MS2 modes high or low, the resolution will depend from full step, half step, quarter step, or 1/8 of a step. Okay, so this is essentially to drive the. So when we are putting MS1 low and MS2 low, then what would happen is it will be in full step. Okay. Whereas if you put MS1 high and MS2 low, then it will be in half step mode. So you can have full step mode and micro stepping mode. In micro stepping, of course, you can get finer and finer steps. Okay, this we'll see as we go along. Now this figure is showing us the connection diagram. Okay, of how do you connect the wires in bipolar configuration onto the motor driver board, and this figure here is giving you the actual circuit diagram of the complete layout of the motor. So on the extreme top right is the motor, and the motor has 6 output wires which are coming out, which are connected to your motor driver. Okay, and so 4 of this are, you can look at the 4 colors of this are going and getting connected onto the top part of the driver, which is your coil A and coil B. Okay, and then we are having the direction pin. Okay, the direction pin which will enable the motor to rotate in a particular direction, and these are connected to corresponding pins of the microcontroller board. So as we go along, we'll see how the connection has been made. Okay, so here we see we have a motor at the extreme top, and then we have the motor driver board, and then which is connected to the Arduino microcontroller. What we'll do here next is I'm going to upload the program. So let us upload the program. So let us connect the Arduino board. So the Arduino board has been connected, and now it is detecting the board saying that Arduino Uno board is connected on COM3. Okay, now this is the program of the stepper motor. The first few lines are basically giving the what it is giving is the comments of the line to understand what this is doing, and then it is also giving us that in microstepping settings that how is the MS1 to be set and how is MS2 to be set. Okay, that if you want to go into different modes, for example, full step. So if you look at line number 13, it is saying MS1 is low and MS2 is low. In that case, it is going in full step. Okay, if you are putting MS1 line number 16, MS1 high and MS2 high, then it is 1/8 of a step. Okay, now coming back to the actual program, it starts from line number 22. So it is defining the direction pin as pin number 3. So the direction pin of the motor driver is being connected to the third pin of the microcontroller board. Then step pin is 2, the MS1 is 4 and MS2 is 5. Okay, now we can see this further. So line number 20 says serial print, enter the number of steps of the motor. Okay, so we have to enter the number of steps of the motor, and based on it the program sequences to the mode it is going in. Okay, so the first part of the experiment says that we have to run this, we have to compile the program, and then we need to download the program. Okay, and then we need to download the program. Okay, before we compile the program, let me show you the various parts of the stepper motor. Okay, this is an opened up stepper motor. So if you can look at the stepper motor here, this is the stepper motor. Okay, and you can see the bearing which mounts on the shaft, and the windings you can see, and there is the rotor which is inside. Okay, so that inside part is the rotor, and the outside part is the stator which has the windings. Now you can see the teeth on either side. You can see the teeth on the windings. Okay, and you can also see the teeth on the rotors. Okay, so this is an opened up section of a stepper motor. So if you want to close it, then basically we'll put the connections onto the stepper motor and close it. Okay, it's going to come in. We can open and take out the rotors also. Okay, so here we have opened up the rotor, and you can see that the rotor has teeth. I was talking about A and B. So it has two sides, and these are the teeth on the rotor. Okay, there are two of these teeth, A and B, on the rotor. You can look at the stator also. So this is the stator. The stator also has teeth inside. Okay, now if you look at the motor driver, so how this would happen is this goes inside there now, and these are magnets, permanent magnets, so it pulls and it falls into place. Okay, so there you can see the. Now if you look at the driver, so this is the motor driver, and I talked about the various. That is the motor driver. Yeah, so you can see the direction pin. So here you can look at the direction pin, which is right here. That is the direction pin. This is ground. Okay, and on the top we can see the MS1 and MS2 pins. So there is, you can see there is MS1 here. Okay, there's MS1 and the MS2 is up on the other side. Okay. Yeah, okay, so these are the connections, and these are the two coils which is marked as coil A. Maybe if I come this side, you can see this is marked as coil A. On top there it is marked as coil A. You can see on the top there it's marked as coil A and coil B. So there is A there, and just beside that is B. Okay, so this is the driver of the stepper motor that we are going to connect to the Arduino microcontroller. Now this is the connected diagram. Okay, so this is the connection which has been made. Okay, so you have the microcontroller. Okay, so that is the one that is holding up now is the motor driver. All the connections have been made as shown in the figure, and then it is connected to the Arduino microcontroller in the corresponding channels. Okay, so here it is connected to the corresponding channels of the Arduino board. Okay, and on this side is your stepper motor, and we have put, so here basically we have put a marker on top. So at the bottom you can see that there is a stepper motor there. There is a stepper motor, but outside on the top we have put this marker. So when it rotates, we know by how much degrees it has moved. and there is a protractor fixed on top right here, so that we know exactly what is the angle it has moved and how many steps. Okay, so let us run the program now and see. So we can run the program now, and it says, so you can see there, it is saying enter the number of steps for the motor. So we have entered, so you can see we have entered 50, enter the number of steps moved 50, and the motor has moved by 50. Okay, let us go a little slow. Okay, so we are seeing again, enter the number of steps on the motor, and then first let us look at how many steps.
So 50 and the delay.
50 steps are being entered. And we can see the stepper motor which is moved by 50 steps. Okay, so enter maybe another 50. So we are entering 50 steps, move by 50 steps. And 50 steps corresponds to how many degrees here? 100 degrees. Okay, so based on that we can also see how many degrees it has moved, and based on that we can compute the number of steps. Okay, so 100 divided by 50 is how many steps it took. Okay, MS1 is MS1 is low, whereas MS1 is high and MS2 is low. So MS1 is high, so I change it to high here. So here I change it to high. Okay, so I've changed it to high now. Okay, now what we can do is we can refresh it and then upload the program again. So uploading the program again. Okay, so let's now look at the different modes by which we can operate. So as I had explained some time ago, and also in the program, it is written right at the beginning of the program. If you see, before we run the program, it is written here, the microstep settings. So we can change the MS1 is given as low and MS2 is given as low when we started off with. Okay, and that means full step. Now full step, the second is we will change it to half step, that is MS1 is equal to high and MS2 is equal to low, and then we'll change to half step. After that we'll make it quarter step, then we'll make it 1/8 step. Okay, and then correspondingly here what we'll see is by how much or how many degrees it has moved. Now this is moving anti-clockwise direction, so we need to be a little careful to see how much it is moving in the anti-clockwise direction. Okay, so at the current moment it is somewhere around, we can see it is somewhere around 10 degrees. Okay, it is positioned at 10 degrees now. Okay, so it is positioned at 10 degrees on the protractor. Okay, so what we can do is we can run it now. So we can go to the part of the program which actually shows. So we have come to the part of the program which is here. Okay, this part of the program which is showing digital write, MS1 low, MS2 low. Okay, they both are low, meaning that it is in full step mode now. Okay, now we can run it. So here I'm going to enter, let's say, so we can enter 50 maybe. Let me enter 50 here. So that is 50. It is entering 50. And that enters. Again, let us look at, it is at position 10 degrees. It will go anti-clockwise, okay, for 50. So I press enter. And this is moving in steps. Okay, so it has gone up to 280. Okay, so 280 means 90 degrees it has moved, right? Total range of motion it has moved is 90 degrees. So which basically means that we can calculate now that how much is one step. So for one step, how many degrees it has gone. Okay. Okay, so this is the first experiment in full mode. Now for the second experiments, what we do is MS1 is MS1 is low, whereas MS1 is high and MS2 is low. So MS1 is high, so I change it to high here. So here I change it to high. Okay, so I've changed it to high now. Okay, now what we can do is we can refresh it and then upload the program again. So uploading the program again. Okay, now it's asking me number of steps again, so let's keep the same number of steps, which is 50. Okay, so I'm keeping it to 50 steps, and I press enter, and then we watch this again. So from 90, where does it go? Okay, it went exactly half. Okay, so you can see it's gone 240 to 280. Okay, so it has gone exactly half of 90 degrees. So about 45 degrees it has gone. Okay, now what we do is we further reduce it. So this is half step. Okay, now we reduce it to a quarter step. So we make low and high. So MS1 is low. So I'm changing MS1 to low, and the other one to high. So the other one is being changed to high. HIGH. Okay, this is being changed to high now. Okay, so MS1 low and MS2 high basically means that we are in quarter step mode now. Okay, so I refresh this again and I download the program. And again we are going to enter 50. Okay, now let's look at the position carefully. Where is the position of? So it is somewhere around 240. Okay, so that's about 240 degrees. Okay, so when I press enter, I'm pressing enter, so this will start moving from 240 to it went up to about 215. Okay, that is quarter step now. Okay, now if you want to make it 1/8 of it now, 1/8 step, then what we do is we can change it to high and high. So MS1 is high and MS2 is also high. So I change it to high and high. So both are high now. Okay, MS1 and MS2 are both high. Okay, now it's asking me again, enter the number of steps. So you can see here it is saying enter the number of steps for the motor, and let us enter 50 here again. So, and let's look at this one again. So it is exactly at 215 degrees. So if I press enter here, so it has gone only till 215 to it has gone to 205, hardly 10 degrees it has gone. Okay, so this is basically showing me that it is doing the different steps in different modes, in full mode, half mode, quarter mode, and 1/8 mode. Okay, so this is how we can change the step size for this stepper motor in full mode or in micro stepping mode. Okay, so now we can calculate, if you want to calculate that, how much it has moved. Okay, so let's now look at the different modes by which we can operate. So as I had explained some time ago and also in the program. Okay, our next experiment is the servo motor control using the microcontroller. Okay, so in the a couple of classes back we had talked about the internal construction of the servo motor. Now the servo motor essentially means a DC motor which is connected with a position sensor in closed loop control. That is the difference between a normal DC motor and a servo motor. So if you take a DC motor like shown here, so this is a DC motor and there is a position sensor like a potentiometer. So in this case it's a potentiometer. So it's in a position control loop, closed loop position control loop, and hence it is called a servo motor. So what are the various components of this? One is the DC motor itself. Then we have a motor driver, which is basically operating as a comparator here. Then we have a potentiometer, which is measuring the position of the output link, okay, or the output shaft here, and there's a gear in there. Okay, now this is connected to the microcontroller board, and the microcontroller board provides a PWM signal to the pulse converter of the servo motor. Okay, now unlike a DC motor, in which case the PWM signal is converted to an average voltage which is given to the DC motor, and that basically controls the speed of the DC motor. But in this case, the PWM signal primarily controls the PWM signal basically controls the position of the output of the servo motor. Okay, that is the basic difference between a DC and a servo motor. So if I give a particular PWM signal with a particular pulse width, then this motor will go and stop its or the shaft will be positioned at that particular angle. Okay. Now another thing to note, that it is important to note that the PWM period time between pulses remains constant at 20 milliseconds. Okay, that we need to do. So what we'll play with, or what we're going to change, is the on time and the off time, high and low time, and the total of that has to be 20 milliseconds, okay, or 20,000 microseconds. So this is the basic servo motor, and at the output of the servo motor there are three wires. One is the orange color wire, red color, and the brown color, and each of this is connected this way as shown. So the orange one is the one that produces the PWM pulse, the red is positive, and the brown is negative. Okay, and this is what we mean by a PWM pulse. So in this particular case, you can see just below this figure here in the middle is showing that this is my 20 milliseconds of the total pulse width, and in which case the duty cycle is 1 to 2 milliseconds only in this particular drawing. Okay, this is called the PWM period. So the PWM period is 20 milliseconds, which corresponds to your 50 hertz. Okay. Now what are we going to do? We are going to have three experiments here, or three tasks rather. And the first one is we have a built-in PWM signal generator from the PWM from the Arduino microcontroller, and we are going to drive the motor using the custom-built PWM program. That's the first one. Okay. Now the second one is there is a servo library where we are going to use the already built-in servo library that was built in the first part of the experiment, and then we are going to move and stop the motor at different angular positions. Okay, and in the third experiment, what we are going to do, so let me come here. Yeah. So these are the various tasks. First is servo control using the built-in PWM signal through a microcontroller. The second is control the servo using the first program that is built in, and go and stop the shaft position at various locations. The third is control the servo position, the output shaft position, using a potentiometer. Okay, so that is the main objectives of our task for today. Okay, for this experiment rather. Okay, so what we'll do is the task manual. Let me look at so this is the microcontroller and the connection. So this is how the microcontroller is connected to the servo motor. And the first is we are going to control the servo using pre-built libraries. Then we are going to, that's the second one. The third one is control of the servo using a potentiometer. Okay. Okay, so let's so we have servo motor program, and we have our first servo task 1. So let me open servo task 1 and explain the program. Okay, so first is this is the program, and let us connect the board. So you can see board is not connected. It's saying select board, means it's not connected. Okay, now we have selected the Arduino Uno, which is connected to COM3. Okay, now the first part of the program is telling us about the pin mode. Its servo pin is an output pin. Okay, so it is connected to pin number 9. So pin number 9 is a PWM pin. This we saw in the previous experiment also, where we are generating PWM signals using the pin number 9. Now it is telling us these are the command lines 11 to line 23. So it's saying the total cycle is 20 milliseconds at 50 hertz. That means that is the width of your square pulse. And we have to ensure that the on time and the off time has to be 20 milliseconds. Okay, and that will determine how much time it is on and how much time it is off. So if you come down a little bit here, it is saying line 25, 26, 27, 28. It is saying digital write servo pin high. Okay, and for how much time? It is saying 2300 okay, microseconds. Then digital write servo pin make it low. For how much time? It is 17,700. So if you add this 2,300 and 70,700, it becomes 20,000. So that is corresponding to 20 milliseconds of the PWM period. And this will take it and stop it at some position. Okay, so let us now look at the servo motor. Okay, so this is a very small servo motor. You can see this is the very nice. You can see the inside also. Okay, so it's in transparent box. So you can see the DC motor, which is the one in the extreme here is the DC motor. Okay, so let us look at the DC motor. So that part is the DC motor. Okay, this one which you can see here is the DC motor. Okay, that is the DC motor. Then there is a potentiometer which is connected there. Okay, and then this is the controller circuit which is given at the bottom. And the output of the motor has a gearbox, which you can see is a plastic gearbox, and then finally it comes to the output there. Okay. So whatever we want to connect, we can connect to the output shaft. Now this is the microcontroller connection which has been made. Okay, so this is the Arduino microcontroller to the various pins which has been made. The connection has been made already. Okay, and then this is again we have put a protractor and an output link. So when it rotates, we know exactly how much it has rotated. Okay, that is how we have designed the experiment. Okay, so first let's look at the pin position. So the pin position is at 0, if you see very carefully. So the pin position is at 0. Okay, pin position is exactly at 0. So it's the link which is going to rotate. So now if I compile the program and then I will upload it. So it has rotated to how many? From 0 degrees it has gone to 170 degrees. Okay, it is going somewhere near 170, 180 degrees. Okay, it has gone to 180 degrees. Okay, so basically we have changed the position from 0 degrees to 180 degrees using this. Okay, now if I change, so if I want to bring it to 0 degrees, then what I should do? इसको 0 कर देगा क्या? So I want to bring the angle back to 0 again. So that's 20,000 now. Okay, so I've changed the. Okay, that is 20,000. So what we can do, we can compile the program again and then download it again. So it has come back to 0 again. Okay, now there is a little bit of play somewhere, so there is a little bit of error there. Okay, so that is how we basically control the position of the servo motor by changing. Now I can change the values of the high and the low values. Okay, the servo pin high and low, the amount of time they are on, but I have to ensure that it is always 20,000. Okay, to make it go and stop in some position. That's how you can make and go and stop in some position wherever you want it. You just have to you can have a kind of scaling, and using that scaling we can actually control this time, on time and off time, and go and make it stop at whatever angle you want. Okay, so this is our task number 1 for the servo motor control. Next, what we need to do is look at task number 2. So in task number 2, it will call task number 1. So this is my task number 2. Okay, so this is my task number 2. Okay, so in task number 2, you can see that in line number 13, it is also calling the servo.h. Okay, or it is that servo is calling my servo. So create servo object to control a servo motor. Okay, and it has including the built-in program of servo.h, okay, which was the previous one. So here what we are doing is line number 13, it says position 0. So what we can do is we can enter the position there and it will go and correspondingly stop in that respective position. Okay. So what we can do here is maybe we will change it to, let it be 0, okay, to start off with. So I compile the program. Okay, the board has not been set. Board is set now, so we compile the program. Okay, and then we go and run the program. So now you can see that it has gone to number exactly at 0 and is stopping there. You can see that it has stopped exactly at 0. So now suppose I want to stop it at let's say 90 degrees. So I can put 90 here straight. So here what I can do is I can put 90 straight in there, and then okay, now it has gone, you can exactly see that it's exactly at 90. Okay, so it is exactly at 90. So you can change it again to maybe, we can make it 180 degrees. So here we are changing it to 180. 180 degrees. That's 180 degrees. So what we do is again compile the program and download it. So it has gone to 180 degrees. So any angle you can go and make it stop. Okay, this is a very, very useful motor and very simple program where you can make you can make a serial manipulator, or you can make a mobile robot, and you can go and make it stop at whatever location you want. Okay, so if you're having a serial link manipulator, each of the joints we can put. As we proceed, our next experiment will probably be a serial manipulator, in which every joint has a servo motor, and we can very easily go and control the angle of that corresponding link by using this very simple program. Okay, so now next is our, so in task number 2, it will call task number 1. So this is my task number 2. Okay, so this is my task number 2. Okay, so in task number 2, you can see that in line number 13, it is also calling the servo.h. Okay, or it is that servo is calling my servo. So create servo object to control a servo motor. Okay, and it has including the built-in program of servo.h, okay, which was the previous one. So here what we are doing is line number 13, it says position 0. So what we can do is we can enter the position there and it will go and correspondingly stop in that respective position. Okay, so what we can do here is maybe we will change it to, let it be 0, okay, to start off with. So I compile the program. It's also again using that servo.h program. Okay, so here basically the objective is that we are adding a potentiometer, external potentiometer. So as you rotate the potentiometer, the corresponding angle will be passed on to the microcontroller, and it is going to take the servo motor to that corresponding position. Okay, so that is the basic function of this program. So here we are again the same connections. The only addition that we have made is that we have connected a potentiometer. That's a potentiometer, and the potentiometer is connected to the microcontroller board as shown here. Okay, to this corresponding number of pins. Okay, and if you rotate so it is now at what position? It is at position 180, I think. We had taken it to 180, right? So yeah, it is at 180. So now if we rotate the potentiometer, let us rotate the potentiometer. Okay, I need to run the program. Let me compile and run the program. Okay, so it has come to 0 because starting is from 0. And as we are moving the potentiometer, As we are rotating the potentiometer, the corresponding angle is rotating. Okay, the link is also rotating. So you can see that this is the potentiometer. So when we are rotating the potentiometer by our finger, the link is also rotating. So you can see that. Okay, so this is the third part of the experiment where we have controlled a servo motor using an external potentiometer. So this is a servo motor which is extremely important for us in our robotics experiments because we have made very simple linkage systems, serial arms, mobile robots using this servo motor, and it's very easy to control this servo motor. Okay, so today in our experiment what we looked at was the servo motor control and the stepper motor control. So first we started off with the stepper motor, and in which we saw that the rotor of the stepper motor had two lines of poles. We call them the A and the B. And based on the MS1 and MS2, how we set them to be equally high. If both are high, then it becomes full step. And correspondingly, we can make it half step, we can make it quarter step and 1/8 step. So stepper motors can be operated in open loop, whereas for the closed loop, we are using a servo motor. Now the servo motor control is also very easy. By changing the pulse width of your PWM signal, we can very easily go and stop or position the link, the last link of the servo motor at the desired location. So servo motors will be used by us extensively, and it's very easy to build robotic devices using servo motors and to control them. So we'll stop here today. Thank you.